Hey guys, Mr. T here, just doing another video. This one's on the 2019 General Mathematics exam. Been doing them for a while now, about 4.5 hours. It might be a bit flaky. Hopefully I don't forget anything. Just going to do it completely live. So see how we go. Alright, page 1. Nope, not a real page. Okay. Council is constructing a new playground. Project involves tasks A to H. State the task that takes the longest time to complete. We'll look for the time in weeks. Task D at time of 5. We'll list all the tasks that must be completed on time in order to cause no delay. So it's asking for the critical path. Look for anything that has no difference between EST and LST. So you're going to have A, C, F, H. Calculate the minimum completion time for the construction of the playground. Well, because you found the critical path, you can just add those durations together. So 2 plus 1 plus 2 plus 4, 8, 9. 9 weeks to complete the program. If a network diagram to be drawn for this project, which task would require a dummy link leading into it? So look for shared prerequisites, but not all the same. So the shared prerequisite is A, and the dummy link goes from A to the task with other prerequisites. So it goes from A to D. So which task would require a dummy link leading into it? Task D would require a task leading into it. No, that's question 1, done. Question 2. Life expectancy, how long a person expects to live from when they're born. Plotted for you. Use linear model, state the coefficient determination. So you haven't been given this, you have to put the data in yourself. Stat, edit, clear your lists. So go up to the list title, press the clear button, press enter to indicate you want nothing in there. So the year of birth is the independent variable determining your life expectancy. So 1890, 1934, 1955, 1972, 1987, 1999, 2003, 2007, 2016. 47.2, 49, 67.1, 67.8, 72.7, 76.2, 77.8, 79, 80.4. They want me to find R squared. Coefficient determination, so stat, calc, lin reg. It says using a linear model, so lin reg. So I got an R squared. R squared is equal to 0.9. It says correct to 3 decimal places, so 0.928. 3 decimal points. Describe the strength and nature of the relationship between the variables. The relationship appears to be linear. R is 0.96, so strong, and in the positive direction. Is that page done? Moving on. The linear regression equation for these data, state the values of A and B correct to 3 decimal places. Well, on my calculator, A is 0.293 to 3 decimal places. B is negative 510.099 to 3 decimal places. Write the equation using the appropriate variables. It's not telling you in terms of the actual variables in the question, so you're just going to write it y is equal to 0.293x minus 510.099. No, it does tell you to use the right variables. I'm not reading it correctly. So life expectancy is equal to 0.293 times by n minus 510.099. Some time wasted already. Using the equation from your answer to part C2, predict the year of birth when the life expectancy of Australian males will first reach 100 years. So life expectancy you are given, it's 100. 0.293 times by n is what we're trying to find. Take 510.099. I need to add 510.09 to both sides to balance it. So it's going to be 610.099 equals 0.293n. The opposite of timesing by 0.293 is dividing by 0.293. Divide both sides by 0.293. 610.099 divided by 0.293. N is equal to 2082.25 to 2 decimal points. Therefore, year 2082 for life of 100 years. One of the values for life expectancy in the table has been recorded incorrectly and appears as an outlier. Identify which one of the points below is most likely to be an outlier. Tick the appropriate box to indicate your answer. So I'm going to have to use my my printout, so I don't need to turn back a page. So you've got a pretty much straight line there, but you've got 1 point between 1920 and 1940 that doesn't seem to be following the straight line trend. So between 1920 and 1940 is going to be 1934, and it's just along or just below the line of 50, so it's going to be 1934.49. Remove the point that you identified in part E from the data and find the new linear regression equation. So it's asking you to redo all of the fitting of a line with this removed. So go to your stat edit, highlight 1934 in column 1 and press clear and enter. Not clear, you press delete, and then on 49 in column 2 you press delete. And so you'll see the numbers bounce upwards. Essentially, you've just removed that data point. So now you go stat, calc, linreg again. So now find the new linear regression line. L is going to be 0.263. And so I'm writing it to the same as it was before. Minus 449.322 to 3 decimal points like it was before. And it's calculate and state the effect that removing the outlier will have on the prediction you made in part D. So you're doing the same calculation again with a slightly different model. So 100 is equal to 0.263n. Take 449.322, add 449.322 to everything. So it's going to be 549.322 is equal to 0.263n. Divide both sides by 0.263. 0.263. N is going to be 549.322 divided by 0.263. is 2088.68 to 2 decimal points. Therefore, increases year of birth to 2088 for life expectancy of 100 years. It's 6 years more. 6 years later is a better term for that. 2082 to 2088. Alright, that's that question done. Question 3. The residents of a retirement village need 275 grand to upgrade the village facilities. They obtain a 5-year interest-only loan. So flat interest rate of 5.2. Calculate the quarterly interest-only payments. So interest only is SI is equal to PRT. They need 275,000 times by the rate as a decimal, 0.052 times by the number of years, 5. 275,000, make sure that looks like a 5, times by 0.052 times by 5 is 71,500. But we want the quarterly interest payment. So 5 years, 4 quarters a year, that's going to be 20. So 71,500 divided by 20 is equal to 3,575 quarterly interest payment. Interest payment. In order to repay the loan, the association sets up a sinking fund and plans to make monthly payments. Over the 5 years, it has a rate of 4.3, compounding monthly. Calculate the total cost of the interest-only loan. So we need to work out what the payments are into the sinking fund. And it's going to be monthly, so 12 times by 5 years is going to be 60. Well, we don't need, that's why they've given you no space. We don't need to use TVM solver because you're given the payments. So you're making sinking fund is going to be 5 years times 12 payments a year. Payments of $4,116.44 into the sinking fund. 5 times 12 times $4,116.44. $246,986.40. And then the interest only is equal to 71,500. So the total is going to be those two added together plus 71,500. 318,486.40 for interest only loan and sinking fund. Calculate the value of the sinking fund at the end of the first year. Now we use TVM solver. 1 year's worth of payments, 12 payments a year, is equal to 12. The interest rate was 4.3. PV was, they didn't say anything, so it starts off with nothing. You're told the payments were $4,116.44, so that's negative because it's going into the bank. You're working out what the fund gets up to, so calculating FV, payments per year and compounding periods per year, both 12. Apps Finance TVM solver 12, 4.3, nothing, negative 4116.44, 12 for both at the end. FV comes to $53.82.54 to 2 decimal places. Therefore, sinking fund is at $50,382.54 at end of first year. calculate how much interest the sinking fund will earn in the first year. So it's an investment, so interest is equal to the future value, which is $53.82.54, minus the payments made into it and any starting amount. So you started off with nothing, plus you made 12 payments of $4,116.44. Do bed mass. So 12 times by $4,116.44 at nothing, and then 5382.54 minus second answer gives you $985.26. Interest earned in first year. Is that page done? State why the association could expect the sinking fund to earn more interest in the second year than in the first year. Well, it's because it's compounding interest, so you just need to explain that. It will earn more interest in second year because there will be more money in the fund. And compound interest, so just long you mentioned compound interest calculates the interest based on current balance. So interest is calculated from a bigger number in the second year. That's that page done. I need a sip of coffee. I'm staying up late. Question 4. In tennis tournaments, service times taken by a player to serve the ball. Service times were recorded. They're normally distributed with a mean of 20.3, standard deviation of 2.4. Calculate the percentage, so normal CDF, expected between, so normal CDF, expected to be between 18, so lower is 18, upper is 23, mean is 20.3, standard deviation is 2.4. Second vase, normal CDF, 18, 23, 20.3, 2.4 is equal to 0.7008 to 4 decimal points. Therefore, 70.08% of service times between 18 and 23 seconds. Calculate longest service time that would be within the fastest 2% of service times. So I have an older calculator, so I need to do the conversion. My cat wants to get up, but I can't let him. So fast serves are here, slow serves are here. The fastest times, no, I don't need to do a conversion. The fastest times are down here, the bottom 2%, so the tail is on the left, so I don't need to do any conversion. I'm finding a time, I'm given a percentage, so it's an inverse normal question. The fastest 2%, so 0.02. The mean was 20.3, the standard deviation was 2.4. For those people with a new calculator, the tail is on the left. So second vase, inverse normal, 0.02, 20.3, 2.4. I don't get to set the tail, but if you've got a newer calculator, you can. 15.371, 0 to 4 decimal points. Therefore, longest service is 15.3710 seconds. In the fastest 2%. Tournament rules require that a player be penalised if their service time is over 25 seconds. Out of 12,500 serves, umpire issued service times penalties 53 times. Calculate the proportion, so that's a normal CDF. Exceed 25, so I'm interested in everything from 25 up to infinity in the right direction. 20.3, 2.4. Second vase, normal CDF. 25 second comma for E, 99. 20.3, 2.4. 0.0251 to 4 decimal points. Therefore, 2.51% expected to exceed 25 seconds. Using your answer to part C1, discuss whether or not the umpires are applying the service time penalty according to the rules. Well, we expect 2.51% to exceed and be given a penalty. So 0.0251, and there was 12,500 serves made. 0.0251 times 12,500 gives you 313.75. Therefore, should be about 314 penalties. There are only 53 penalties issued, so looks like umpires are not penalising as many as they should. Okay, is that question done? Another bit of coffee. The graph below shows probability distribution of service times recorded at rural tournaments. At the state tennis championship, the service time was found to be normally distributed with a mean of 18.5, standard deviation of 1.5. I need to sketch two graphs on the same axis. 18.5, so the mean is going to be there somewhere. You need to work out the height. So rural height was 0.4 on 2.4. 0.17 to 2 decimal points. That's 0.17 on our scale. Height for state. 0.4 on the new standard deviation is 1.5. 0.27, 2 decimal points. So how do we work this out? 0.27 divided by 0.17 1.56. So this is 1.6 times the height of rural. So if I could deploy a ruler or something on my screen, I would, but I can't. 1.6, so it's going to be like an extra half, slightly more than a half of the existing one, so I'm going to put the peak up there. Standard deviation is 1.5, so one standard deviation, 18.5, no, yeah, 18.5, 19. It's over 20 and halfway, so your points of inflection are going to be halfway down, one standard deviation away. 20, 21.5, 22, 23, so it should finish at just over 23. 1.5 should finish just over 14. So here's your concave section. And your it's not symmetrical. Try my best on this glass screen. And then the convex section. Okay, so that's that graph done. Next page. Question 5. Activities A to P are part of the setup of a music festival. Network diagram shows these activities. Which activity must be on the critical path? You see that the path goes down to one arrow in E. So E must be on critical path. Forward and backward scans. They're doing everything for you in this test. You know what? I'm going to have a drink then. Take the critical path or paths for the setup of the music festival. So looking for no slack time. Up there. $17, 22. 17 plus 7 is 24, so you've got one there. 22 plus 2 is also 24. You've got two critical paths. Either FK or FG and then J and then N. State the critical paths. So that's why they're setting you up by telling you. There's multiple already. Longest one is A, C, E, F, and G. J, and then N. You don't necessarily need to write the G. You don't need to have that because F is taking longer. So as long as you've done F, G is going to happen anyway. So you don't need to mention that, but I'm just covering my bases here. I'm showing my understanding of that. Or A, C, E, and then going over the top, F and K. Is that page done? Calculate the amount of slack time available for activity L. So to save you turning the page, I'm going to have to do the backward scan properly myself on my printout because they haven't done the box numbers. 24 minus 2, 22 minus 3. So there should be a 19 in a box over L. 22 minus 5. 17 minus 2 is 15. There should be a boxed 15 over G. 17 minus 2 is 15. There should be a boxed 15 over H. 4 minus 3 is 1. There should be a boxed 1 over B. Calculate the amount of slack time available for activity L. So looking at L. Yeah, you needed to do those box ones. It didn't provide them to you. So it's going to be 15 to 19. 19 take 15 is equal to 4. Therefore, 4, was it days? 4 days slack time for L. The setup of the music festival has been changed. The precedence table for the new setup is below. Activity queue hasn't been drawn. Use the info on the table above to add activity queue to the network diagram below. So everything's been drawn for you except Q. Q requires A. So Q is going to come out of here. Then we just need to work out what requires Q. N requires Q, J, and L. N is coming out of J and L right now, so Q needs to join in and join up with that node, and Q is 12 in duration. Complete the forward and backward scan, so blue and red. 0, 5, 3, 8. 8 plus 5, 13, 16, 15. 15 plus 3, 18, 16 plus 5, 21. Have I forgotten about the 12? What's 5 plus 12 plus 5? 17. No, so 21. 15 plus 4, 19. 19, 21, 22. Or 21 plus 2, 21, 22, 23. 23. Backward scan. 23. Take 3 is 20. 23 take 2 is 21. 20 take 4 is 16. But 21 take 3 is 18. 18 in a box. 20 take 4 is 16. 21 take 5 is 16. 16 take 3 is 13. 16 take 2 is 14. 13 take 5 is 8. 8 take 3 is 5, but 21 take 12 is 9. 5 take 5 is 0. 8 take 4 is 4. 4 take 3 is 1 on B. Complete the scans. Discuss how the change to the setup of the music festival has affected the optimal solution. It has reduced the completion time by 1 day. You'd hope there was an improvement, otherwise what was the point of changing it? And there are no longer 2 critical parts. That's that page. Question 6. Lewis wants to install an in-ground pool, quoted 32 grand. He can afford to save 500 per fortnight, decided into an account of 3.2, compounded fortnightly. Show that it will take 62 fortnights. So we're finding N. The interest rate is 3.2 PV. It doesn't say he's starting off with anything, so nothing. PMT, we're told he's saving 500 per fortnight, so putting 500 in the bank, negative 500. FV, he's saving up for 32 grand. PY and CY are both fortnightly, so 26. Apps Finance, TVM, 3.2, nothing, negative 500, 32,000, 26. Sol 4, N, alpha, enter, 61.64 to 2 decimal points. Therefore, it will take 61.64 fortnights, which is approximately equal to 62. Lewis wants to install the pool in 2 years' time. Calculate how much he has to pay into the account per fortnight. So he wants to do it in 2 years, and it's going to be 2 times 26. 2 times 26 is 52. Interest rate is 3.2. Starting off with nothing. Solving for the payments, because we want to work out how much he has to put in if he wants to reach the goal. FV is 32 grand. PY and CY are still 26. Alpha enter. PMT is negative $596.28 to 2 decimal points. Therefore, Lewis must pay $596.28 per fortnight to achieve the goal. I hope I haven't done any spelling errors in these videos. I can't go back and change them. Assuming inflation averages 1.7% per annum, calculate the expected cost of installing. So value indexed for inflation is equal to, the cost currently is 32 grand, but we want to see what happens if it's inflated. Plus 0.017 is the inflation rate, as a decimal to the power of 2 years. Use bed mass. 1 plus 0.017, square it, times by 32 grand. $33,097.25 to 2 decimal points. Expected cost in 2 years' time. That's that question done. Moving on. Lewis decides that needs a pool installed as soon as possible. He's desperate. He wants to take out a 3-year loan for 32 grand. He's got 2 options. Charges 7.2% per annum, compounding weekly, no fees and charges. Option B, compounding weekly, establishment fee and ongoing charge of $5. Find the comparison rate for option A and option B. So option A. Remember, the comparison rate of a loan is just the rate when there's no fees and charges. So comparison rate is 7.2% per annum as no fees, charges. So lucky for you, you don't need to work that out. Please don't waste time working that out. Option B. N. It's weekly. It's for 3 years. 3 times by 52 is 156. Interest rate is 5.39. We want to work out what the payments are with the loan with an establishment fee added. PV is going to be 32 grand plus the $495 establishment fee, so 32,495. PMT is what we're trying to work out because it's considering the establishment fee. FV0, PY and CY are both 52 because it's weekly. Apps Finance TVM, 52 times 3, 5.39, 32,495, nothing, 52. Solve for PMT, negative 225.70 to 2 decimal points. Now we have to do the TVM solver again. N is equal to 156, but we're solving for I now. The loan was 32 grand, but the payments are negative $225.70, and also considering the $5 per week fee, so it's going to be negative $230.70. FV is going to be 0, PY and CY are both 52, 32,000, negative 230.7. That comes to 7.94 to 2 decimal points. Therefore, comparison rate is 7.94% per annum, considering the fees and charges. Lewis should select option A because it's a lower rate, and this is a loan because it has a lower comparison rate of 7.2% per annum compared to option B with 7.94% per annum, considering fees and charges. All right, that's that question done. Moving on. Statistics question, question 7. I'm going to check that email as well. There's going to be a delay, but whatever. I don't like to leave emails waiting. This could be a break in the exam of you having a snack or something. No, it's not an email that I need to reply to. Following table shows the number of subscribers to a streaming service. They referenced their data. The linear regression is y is equal to, yep. Complete the table of residuals for this linear model given your answer. You need to put the data in and find the residuals yourself. Clear list 1, clear list 2, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 7.5, 9.4, 12.3, 20, 23.5, 33.3, 44.4, 57.4, 74.8, 93.8. Stat, calc, linear regression. So it's telling you it's linear, linreg. So it's run a linear regression now. So you can go stat, edit again. Go to list 3, press second stat, scroll down to 7 resid, and it's going to put the residuals in for you. So just double check that the residuals they've given you in the exam match 11.94, 11.942 on my calculator. So they're matching. And to go down to 7, it's negative 3.6. We'll do it to the same decimal points they did, to 2 decimal points. Does it ask you to add that or something? No, just put it into the table. Complete the table below for the Netflix data. So what it's showing here is it wants the exponential model. So I have to go calc again with that same data, scroll down to expreg and do an exponential regression instead. So y is going to be 7.47 times by b 1.34 to the power of x. And that's to 2 decimal points. R squared is 0.995 to 3 decimal points. Okay, moving on. Circle the letter A, B, or C next to the plot that best represents the residuals for the exponential regression. So exponential, you'd want to look at the residuals. So I'm going to go stat, edit. I've just done an exponential regression. I'm going to put the residuals in list 4. So second stat, resid. I'm going to put the linear residuals into list 4. So I've got negative 7 for 9. So that looks like it's here. Negative 0.695 for 8. So that does look like it's matching. The only other one that has a negative for the data point at 9 years is A, but that's nowhere near negative 7, so it must be C. Using evidence from parts A, B1, B2, discuss which model best fits the Netflix data. Alright, I'm going to use as much evidence as possible. A shows clear curved pattern. For the residual plot for linear regression. So trying to fit a line to that Netflix data is not appropriate because there's a clear pattern in the residual. That's one strike against it. B1 shows that coefficient of determination, R squared, is significantly closer to 1 with exponential regression, and B2 shows no clear pattern for residual plot for an exponential regression. Therefore, these things show an exponential model best fits the... Okay, can't write today. Getting a bit sleepy now. Best fits the data. That's that page done. On a competing streaming service, Company Z also starts at the beginning of 2007. It's got this exponential equation. Explain the meaning of 3.86 in this context. 3.86 is the y-intercept of the model. It shows that there were 3.86 million subscribers at beginning of 2007. By the way, if you're watching this video on YouTube, subscribe, like and subscribe, hit that notification bell, whatever else those YouTubers say. It's a bit of a joke, but whatever. Explain the meaning of 1.409. 1.409 is the multiplier. It is 140.9% as a percentage. It shows that subscribers for company Z increased by 40.9% every year. From when it started, which was 2007. Using the exponential equation, estimate the number of subscribers expected to be the beginning of 2023. So remember, X is the number of years since 2007, so you need to work out, you can't just put 2023 in there. 2023 minus 2007. $16 years. So Y for 16 years is going to be 3.86 times by 1.409 to the power of 16. 1.409 bed mass, so to the power of 16 times that by 3.86. 931.46 to 2 decimal points. Therefore, could expect 931.46 million subscribers by 2023. According to this exponential model, in what year could company Z expect to have 350 million subscribers? So you're plotting, you're trying to solve the equation of 350 is equal to 3.86 times by 1.409 to the power of x. We can't solve that algebraically at this level of maths, so we graph it instead. Graph the left-hand side into y1. Graph the right-hand side into y2, 3.86 times by 1.409 to the power of x. Y equals, clear the old graphs that I had from previous exams, 350, 3.86 times by 1.409 to the power of x. I'm going to set the zoom to standard, so I start fresh. Intersection at. I'm going to try a zoom fit to see if it finds a good zoom for me. So it's drawn the horizontal line for y is equal to 350. Now it's drawing the red exponential line, and it's clearly not going to meet on the screen, so I'm going to zoom out. The horizontal line is in the middle of the screen now. The red line's just drawing and it's going upwards, and they definitely cross on the screen now. So second trace, select 5 for intersect, first curve, second curve, enter, guess, enter, intersection at 13.15. And y is equal to 350. Therefore, could expect 350 million subscribers sometime 13 years from 2007, so 350 million subscribers in 2020. Okay. State a reason why the answer to part C4 might be more reliable than the answer to part C3. Both are extrapolations, so none of them are reliable. Both are extrapolations, but C4 is an extrapolation of 3 less years. So less of an extreme prediction. Cat's going crazy. 3 less years, so less of an extreme prediction. That's that one done. Moving on. A city operates 4 train lines: the airport, Bayside, Circle, and District lines. The number of passengers use these trains. State the number of passengers who use the airport line on a Saturday. Airport, row 1, column 3, 15,000. Use airport line on a Saturday. Thursday to Sunday, each train line closed 1 day for maintenance. Apply the Hungarian to minimize. So straight up Hungarian algorithm. You've got a matrix already drawn here, so use it for your first step. Smallest number 11, smallest number not 8, 7, smallest number 6, smallest number 15. Take 11, take 7, take 6, take 15. Draw the matrix down here. 0, 5, 4, 5. Take 7, 7, 6, 1, 0. Take 6, 9, 13, 0, 2. Take 15, 6, 5, 3, 0. Do the columns now. Smallest number 0, smallest number 5, smallest number 0, smallest number 0. So minus 0, minus 5, minus 0, minus 0. Leave it. Take 0, 1, 8, 0. Take nothing, 4, 1, 0, 3. Take nothing, 5, 0, 2, 0. Done rows and columns now. Cover the zeros with lines. The most I can hit is 2. The most I can hit is 2. Most I can hit is 2. Most I can hit is 1. Select my zeros. Alone in its row, no. Alone in its column, yes. Alone in its row, no. Alone in its column, no. Alone in its row, yes. Alone in its row, yes. Alone in its row, no. Alone in its column, no. Alone in its row, alone in its column. This one's the last to choose. It's going to be there. So, airport, Bayside, Circle, District, airports should be closed on Thursday. Therefore, lines closed on. Airport on a Thursday, Bayside on a Sunday, Circle on a Saturday, District on a Friday. That's that question done. 18. State the minimum number of passengers who would be inconvenienced by the maintenance closures. So I need to use my printout and have a look, so I don't have to go between pages. It's going to be 11 plus 20 plus 6 plus 7 equals 11 plus 20 plus 6 plus 7, 44. Therefore, 44,000 passengers minimum inconvenienced. The city decides to explore the option of doing maintenance over 5 days, Wednesday to Sunday. During the quieter period, for this scenario, number of passengers who use these train lines run as follows. It's not square anymore. State the modification that must be made to this array before the Hungarian algorithm. Need to add a row. Need to add a dummy row. Row of zeros below district. So like this, 2, 3, 4, 5. That's going to be your starting matrix there. Next page. Some of the steps of the Hungarian algorithm have already been done for you. A lot of this exam's been done for you already. Draw lines in the reduced area to show it hasn't been reached yet. Most number of zeros I can hit is 4. Next is 3. Next is 2. Next is 2. There's no more zeros. Draw lines in the reduced area to show. So 4 lines. I do that in red. It's more time wasted. 4 lines, but 5 rows. So, no, I should have written that. Well, the question is 4 lines to cover, but 5 rows. Optimal solution not reached. Use the reduced array above to complete the application of the Hungarian algorithm. So 4 is the smallest uncovered number. So I'm going to draw another matrix here. Leave, leave, leave. Add, add. Take, 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 leave, leave. Take, 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 leave, leave. Take, 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 leave, leave. Leave, leave, leave. Add, add. Cover with zeros now. Cover the zeros now. The most I can hit is 3. The next most I can hit is 2. The next most I can hit is 2. The next most I can hit is 2. The next most I can hit is, well, yeah, the 1, but I'm hitting 2. So I can select my zeros now. Aloneness row, aloneness column, no. 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 Aloneness row, yes. Aloneness row, aloneness column, no. Aloneness row, aloneness column, no. Aloneness row, column, row, column. So I've only got 1 really that's been selected. Process of elimination. So I need something to do. I've got this column. It needs to cover this row, this row, this row. Can't do the middle. It could do the bottom, but this row can't do this, so he can be chosen. The next one, this can be chosen through process of elimination, but then we've got an issue here. We've got these 2 rows and these 2 columns to choose, but they cover the same places, so we can't choose out of those. This is probably going to be a multiple option solutions situation, and I'll check the matrix on the printout just to be sure. And you can see that, yeah, airport, Wednesday and Thursday is 11 and 11. And then the bottom row, which is the dummy link, it's 0 and 0. So they're exactly the same. So this will be a multiple optimal solution situation. It's going to be red, airport, Bayside, circle, district, nothing, airport, it could be Wednesday, Bayside, Sunday, circle, Saturday, district, Friday, and then if airport's on Wednesday, nothing on Thursday. Or, because of the multiple optimal solutions, airport could be on Thursday closed, then Bayside's the same, circle's the same, district's the same because they're chosen, but nothing on Wednesday. Give a complete interpretation of the optimal solution or solutions in the context. I sort of did that already. There are two optimal solutions, lines closed on airport, Bayside, circle, district, nothing, yeah, I'm writing the same bloody thing again. Should have probably read the question, doesn't matter. Or Thursday, Sunday, Saturday, Friday, Wednesday. Both options, inconvenience, a minimum of so looking at my printout, it could be 11 plus 0 plus 18 plus 5 plus 6. Or the other situation, it could be 0 plus 11 plus 18 plus 5 plus 6. What do these add up to? 11 plus 0 plus 18 plus 5 plus 6. 40. That's going to be the same. Therefore, 40,000 passengers. So 40,000 passengers at minimum are going to be inconvenienced with both solutions. That's that question done. One assumption made when using the Hungarian algorithm to make assignments is that both groups must be assigned. This means assignments such as the one in the diagram are not considered. So that's meaning that you're going to assign multiple things to the one group on the other side. Referring to the diagram above, discuss the reasonableness assumption in the context of the question. So it's not always going to be reasonable if people are being used up, for example. But there would be nothing in this situation stopping you in the real world from having maintenance on multiple lines in the same day. This assumption is not reasonable in reality But for this situation, this context specifically, because it would be possible to do maintenance on different lines on the same day. There's nothing stopping that from happening. So referring to this information in the table below, show the solution can be found that affects fewer passages than the solution given by the Hungarian algorithm. So if we're able to do things on the same day, you should just be choosing the smallest numbers. So 11, 7, 6, 15. If you can maintain multiple lines on same day, you would choose the lowest numbers. Therefore, airport, Bayside, Circle, District, on Thursday for airport, Bayside Sunday, Circle Saturday, District Sunday. And how many people for a total of 11 plus 7 plus 6 plus 15. $39,000 customers. Inconvenienced. Right, that's that question done. Question 9, Dakota. So these names wasn't too bad this time around actually. Dakota applies for a 25-year home loan, 350 grand, interest rate of 4.18, compounding monthly. Find PMT, n is equal to 25 times 12. Apps finance TVM solver, 25 times 12, 300. Interest rate is 4.18. The loan is 350 grand. PMT is being solved. FV is nothing. PY and CY are both 12 because it's compounding monthly and the payments are monthly. 4.18, 350 grand, 12 and 12. Alpha enter, negative $1,882.39 to 2 decimal points. Therefore, repayments of $1,882.39, which is approximately equal to $1,880. Calculate the total cost of the loan. Total cost is going to be 300 payments of $1,882.39. It's going to total a cost of 564,717 total cost. State one assumption that may affect the reasonableness of your answer to part A1. Assumed the interest rate stays the same. So your payments don't change. assumed Dakota maintains her repayments. Prior to taking out the loan, she inherits, well, I'm assuming it's a she. That's bad. Prior to taking out the loan, Dakota inherits 10 grand. It's doing an offset account. 25-year home loan has a rate of 4.38, monthly repayment of 19.21. Calculate the balance on which interest will be charged at the beginning of this loan if Dakota deposits the 10 grand in the offset account. Well, it's just going to be $350,000, the loan, minus the 10 grand in the offset. So it's going to be $340,000 balance. Okay. Next page. Calculate the total cost of this loan if Dakota leaves 10 grand in the offset account for the entire term of the loan. So she's got this offset in for the life of the loan. So instead of a 350 grand loan, he's paying for a 340 grand loan with her established repayments. So it's going to be shorter. PV is not going to be 350 grand, it's going to be 340 grand. Her payments were established in the previous question, the previous question gave you it, so 1921.65, not PV. FV is going to be 0, PY and CY are both 12. Apps, Finance, TVM, Solver, 4.38, 340 grand. Negative 1921.65. Alpha Enter on N, it's 284.87 to 2 decimal points. Calculate the total cost of this loan now. Well, she's going to be making 284.87 payments of 1921.65. That equals 547420.44, 2 decimal points. But you have to be careful, she had the offset in the whole time, plus the 10 grand offset. Therefore, 5,57420.44 total cost. So essentially, to make that saving, it cost her the 10 grand offset for the whole period of the loan, so you have to consider that. Hence, state one reason why Dakota may choose the loan with an offset account. It costs less in total, even considering the $10,000 offset for the loan term. So even considering you had no access to the 10 grand for the whole loan, it's still cheaper. State one reason other than having the choice of where to invest 10 grand why Dakota may choose the original loan without the offset accounts. May choose the original. Well, she's still keeping the money. Why would she want the original loan? Apps, Finance, 350 grand. $4.18. Looking for a reason for this. All I can see is the payments are cheaper. The monthly repayments are cheaper for the original loan. That's one kind of weak reason, but you're trying to give one here. Dakota is unsure about using an offset account. Instead, she considers investing 10 grand in an investment account offering 2.3% compounded quarterly. Calculate the value of the investment at the end of 1 year. N is 1 year times by 4 because it's compounding quarterly. 4 interest rate is 2.3 PV. She put 10 grand into the bank, so negative 10,000 PMT. She's investing it. She's not doing anything, putting payments in, so PMT is 0. Solving for FV, PY and CY. Compounding quarterly, so both 4. Negative 10 grand, 0, 4 for both. Alpha, enter. 10,231.99 to 2 decimal points. Therefore, $10,231.99 after 1 year. Calculate the tax that Dakota will have to pay on the investment, assuming that her marginal tax rate is 37.5. Well, tax is going to be the interest earned, which was $231.99, times by 37.5 is a decimal, 0.375. 231.99 times 37, not 37.5, 0.375. $86.19, rounding to $287, rounded to 2 decimal points. All right, next page. Looks like that's it. So that's the 2019 real general maths exam. Hopefully that helps you out, and I'll see you in the next video. That's balances.